my name is Konrad Jędrzejczyk. This will be a joint presentation. At some point, Marek will be taking his part. And today we will tell you something about our challenge and journey of integrating LLM module into the Commodore computers. So, since we are very limited on time, we will be briefly speaking about the background, why we are doing this. We will be comparing what has been done for Commodore 64, especially computers. We'll be talking about the challenge itself, the rules. We will be summarizing what went good and not really. We will be going through the entire process of choosing the right approach. And we will be also very briefly talking about the design of the LLM module. We will also talk about the near future. So let's start. Marek Zmysłowski here, experienced cybersecurity researcher and co-author of cybersecurity books, you name it. He was everywhere, done everything. Me, a little bit similar. I also have some experience, but today we are talking about Commodore computers. So let's start about my collection. I have over, depending on how you will count them, over 110 working computers. Commodore computers, 8 bits. I have everything. I have a dedicated place to repair them. One of them is very special, since my hobby is electronics in the pretty advanced level. I've purchased a copy of PCB from PCBWay from China, and I populated this mainboard with the best possible parts that I could find on Mauser Electronic, mostly, but in total it cost over 1,000 euro. If the capacitor was available with the certification for an extended period of time and temperature, this was the one I was choosing for this computer. So it will last for another 20 years. Most of these ICs are new. Some of them don't have still replacement, and I didn't go through any shortcuts. So this is board 250-407 with TTLs, no 8701 ICs. So guys, if you will be doing something like this, don't go into HDMI. Just stop being poor and buy better grabber. So, a short recap from the past. I presented in Bucharest pen test done by unexpanded Commodore 64, doing stuff with modern systems. So there was cross-site scripting, there was a open relay abuse, there was shell shock. This was actually very fun because Commodore ASCII don't have free chars that were needed to execute shell shock, and I figured it out very late before the conference, so I needed to rush it. But it was done, and it was properly recorded. Here is the network scanner that I also wrote for Commodore 64. It was basically reading banners, and try to log in over Telnet, but it was capable enough. I also have a single video on my YouTube channel where I'm connecting Commodore to the locally hosted LLM at my home. Well, this was a thing 2 years ago. Nobody thought that you can have your own LLM at home. So, why we are doing this? Commodore 64 is a computer that created possibly the best cybersecurity community in the world. There is no comparison to any other machine from this time. This computer already have actually working Bitcoin miner written by Polish guys. It has ported Mario, and the guy who ported it, after 7 years of working, he was sued by the gaming company. You have Commodore 64 working in services still in crankshafts. You have Sonic for Commodore 64. You need to have RAM extension. You have VHS quality video for Commodore 64. You have some kind of Winamp. You have new 3D engines that are still developed, again, by Polish guys, for Commodore 64. Here you have Contiki. This is an operating system for memory-constrained systems. This is the older version with GUI. The newer version is only terminal only, but it works. And except this, we are working on something else that we will be showcasing soon. Not all went well. There was a YouTuber who knew faster than me that the radio on International Space Station was replaced. So they have again COM, and he connected with Commodore 64 to the International Space Station. He was first, but I was better prepared. So this was my equipment. I even made my legal call sign, Sierra Papa 5 Commodore business machine, Charlie Bravo Mike. But he was the first. Everything was prepared on my side. Anyway, the reason why we are talking today is the computers now, they have these dedicated AI modules that you can connect to them and play with the things like YOLO, whatever. You have this for Mac, you have this for PC, and I didn't see anything for Commodore 64, which is obviously the situation we need to address, okay? So the rules of the challenge were, it has to be similar to 80s technology. It can't be like separate big thing that is just lying there, obviously not a part of this computer. It should be compatible with as many Commodore computers as possible. This is not obvious. Remember that these computers at that time had different even connectors, standards, everything within a year. So if you want to have compatibility, you need to usually buy the joystick for this particular machine. So really, even connector for external mass storage devices were different. So yeah, we didn't want to compromise C64 functionality, so we didn't want to overtake the entire computer. There is a dedicated signal for a CPU that will basically disable it, and you can freely access all the stuff on the main board. You can address the memory, seed, VIC, whatever. Should be easily replicable. This is for you guys, and we wanted to create a tool, something that is actually working, not proof of concept. This is very important. So Bitcoin miner is fine, but it will solve the block within 300 years. Nice, okay, but we wanted something more. So we started a research about what was done in the past. This was pretty easy because I have a collection of almost 400 books related to Commodore 64, so I was digging it. But it came out that there is no really coverage of these things in the basic, despite the fact that this computer had a lot of memory at the time. So I've created a machine learning program, and I wanted to showcase it on DEF CON. But the COVID came, and this was actually good for me because later on I found out that there was a guy who made a very similar thing to me in '87. For research, unfortunately. So he did a machine learning with the numbers recognition. My design was a little bit robust because I was using the floppy disk drives who has their own CPU, 6502 and 2K of memory. They were daisy-chained. This is, again, unexpanded Commodore 64. You are just connecting from one floppy to another, up to 5. And they can process the information independently from the floppies. So I've basically made a machine learning software that was recognizing these signs, and they were buffered and they were solved on the another disk drive, so it was streamlined like 5 times more. And I was also using a light pen because Commodore 64 have integrated part when it is exactly monitoring the timing of the pixel generated in the real time on the CRT monitor. So yeah, this very nice. Unfortunately, not really known. So will be this a first AI? We think yes. So the question is, do we have resources and knowledge to do this? We will need to have programming skills. That's Marek. And some of the technical hardware expertise. For example, 2 years ago, I believe, we started to poke around scalable corporate type retrieval augmented generation software, but this is not irrelevant right now. Just to let you know that we have some background in programming these things. This is from the times when the models were accepting just up to 2K of tokens at the encoder. So yeah. Anyway, electronics. Do we have the skills? Yes, I have this dedicated place for maintaining all the computers. So yes, I have also a lot of experience with making some smaller parts for Commodore. That's good. It will be useful. And for this challenge, we'll be using the version C, just because it has LumaFix for a little bit better video output. But this is not really important, just to let you know that this is a version from 1986. It looks a little bit different than to what you can use to. There were 2 main Commodore 64 computers in terms of design. There was a third one in New Zealand, of course, in New Zealand. So we had to select the proper interface. Again, we didn't want to overtake the computer. So if we would take expansion port, then, well, we can do everything with this computer. Like, as I told you, we can disable the CPU and use it as electronics that is connected to whatever. This is not the idea. We still want to have functionality. We want to have third-party software loaded. This is out of the question. Especially that many users right now are using some external data sources through this extension. So no. We would be unable to use, for example, Camelon, Ultimate 1541 to whatever. We don't want to. Floppy. This is a good idea. You can transfer the data over this interface. As I told you, I have quite a lot of experience with these things. However, again, some of the external memory is using this port, and this is, well, it would be difficult to daisy chain anything else on top of it. Bad idea. Tape, no, not because we wouldn't be able to control it. You can, differently in the version 1 and version 2 of Commodore 64, but the problem is that many of the devices that you are connecting nowadays to Commodore computer are powered from this port. So this is, again, no. Obviously, the last thing that is for us is the user port. For this port, people usually were connecting the printers. Nowadays, this is basically unused. If you will look at the Gideon logic or whatever any emulator, they are omitting this port. It's not very popular if you want to have a party and play the game with 4 guys. Then yes, you have these extensions for it, and this would be probably the only use case for it. So we have a plan now. What we should do? How it should look like? So let's explore the original modems that were connected at the time to this port. This is the originally packed Commodore modem that I've unpacked for the purpose of this talk and for the pictures. So this is how it looked inside. I didn't try to register, but there is an option. You have software, you have everything. It looks really, really nice. We also wanted to have something that is usable again. So these computers, these PCs, these MacBooks, they are using external TPU or GPU, whatever you have. So we wanted to have the same, but we didn't want to have this. We didn't want to have Raspberry Pi. Raspberry Pi is big, chunky. This is not the way to go. So we've collected a lot of computers in order to choose one of them that would be supporting our solution. And it came out that we want, again, something small. So we chose a small computer that is not really known, and it is extremely not user-friendly. You are buying this computer, the first thing you need to do is to flash it like a phone, or you will do nothing with it. So we have chosen Radxa 0 with a lot of RAM, actually. 8 gigabytes will allow us to run a lot of software, bigger models even, and, well, you will see. So we have mini computer chosen. This will be our module, external module. But if we want to make it like a product from 80s, we need to have software delivered with the device. So what we can do? Well, I was considering opening this factory sealed floppies for Commodore, but I said, okay, maybe difficult, maybe I will bring this equipment here, I don't know, so let's move somewhere else. Since we didn't overtake our expansion port, we can have still cartridge available. So we've decided to go with dedicated cartridge. This is Magic Desk. You can download it. You can purchase the copy of this PCB design from any bigger provider. We've programmed it. This is the configuration file. You have here some of the terminal software. This was how the process went. Pretty straightforward. Everyone who is poking around it will know this program. This is a very basic one. So we've printed also the case. For this purpose, we purchased a bamboo printer just for this project, and it stays unused a little bit since then. But we have also a capability to build a case for this cartridge. This is how it looks after completion, and we have a part of the software. Marku.
Testing? Okay. Thanks, Konrad. Before we started, I would like to thank you, the organizer, for inviting us, giving this talk. Second day, first things in the morning, after the after party. Thank you very much. And it's probably not related that we are from Poland and we can survive that. Okay. So as you can see, Konrad is a Commodore freak in this tandem, so I will tell you a little about LLM itself. So as Konrad mentioned at the beginning, we want a tool, not a toy. So we want something that really works, not just a POC. We could run something small. There are different models. Recently, there are even models called like random. So they behave like Llama or other more popular model that does return random characters. So we want something that really works. So we decided to use Tiny Llama in the instruct version for our purpose that is built on Tiny Llama. But Tiny Llama itself is not very good with a lot of knowledge, and we want, of course, if this is running on Commodore, it needs to ask the questions about the Commodore, right? So what to do with that? So we decided, okay, let's fine-tune it. Let's collect some knowledge about Commodore, put inside the model, and see how it works. So can we do that? Well, we've got the power. So we built few quite huge machines for that. We have graphic cards like you see the P40. We have a RTX 3090. We have RTX 3080. So we have enough equipment to fine-tune it. Cool. Now we need some data. Of course, you know Konrad is Commodore freak, so of course he had the 360 Commodore book in PDFs collected from, I don't know when it started, but yes, we do have information, we do have a data, we can put it inside LLM. Cool. But how to do it? Okay, we need to pre-process those books, right? They were quite old. Not every book was easy readable. As far as I remember, some of the book, even though they were in PDF, they were just images included in the PDF, right? So we need to use OCR to get the information, and of course prepare in a special way those information to fine-tune it our model. So how we do it? Of course, we ask ChatGPT to help us. So we took those books, we took chunks of those books and sent to ChatGPT for pre-processing in appropriate format so we can use this. It was working. It cost us a little bit, almost a little more than $250 for using ChatGPT API, but we were managed to create appropriate data set for the fine-tuning. So that was cool, and we failed. We failed because the model was too small, so it was not able to handle all the knowledge that was collected in the book, and the knowledge was very, how to say, like detailed, right? Very technical and very detailed. So there was a lot of information that this model was not able to handle. So we failed that. ChatGPT didn't want to give us money back, so they said, "Okay, it's our problem. So we need to find something else." So we decided why not to use a RAG. RAG, which is retrieval augmented generations. For those that are not aware, in the simple version of this, it's just a external additional database that contains information, data, that can be used by LLM model, which was cool. Okay, so we decided, let's build RAG. We already had that experience, as Konrad said, we already were doing this locally for our PCs to building RAG with the models. So we have enough knowledge to build something like this. So yeah, let's use these things. Right now, of course, there's more different type of RAGs right now coming up. Every half of a year, someone is creating new one. But we decided to use the easiest one, the simplest one, right? Naive RAG, which requires only LLM model that will do processing and one more model that was used for text embedding, which is additional model that can cooperate with the database itself. So we decided to choose this GIST embedding model for our RAG, and we decided to use this and run this. Okay, so as you can see, that was only my part. It took 2 months, but I got only 6 slides. Thank you.
And again, if you want to create model for a user who is starting LLM module on the Commodore computer, really not this is not really something usable. So we have a user, advanced user, asking for Commodore 64. This is not exactly a tool, so it actually is a good thing that that we fail. So this is the first attempt, and I wanted you to show my development board. This is a Redaxia computer. You have a connector for external power source. In this case, this is just another power supply, Commodore 64 power supply. You have different states for communication. This is important for anyone who knows how Telnet works. You have some buttons related to software. And the question, why we use this external power supply? The CIA IC that is directly connected to this port in this in Commodore 64 has a maximum of 100 milliamps. And this computer is consuming up to 2.5 amps, which is an issue because of many reasons, starting from the cooling and really zero support from the manufacturer to fix this. You cannot even buy this computer without the pins, so you would need to resolder them in the other side in order to put some reasonable cooling. So it was madness. The MAX232 is used to convert the voltages during the communication. This is the piece that was used in 80s, so it meets our requirements. This is a piece of electronics that you will find in the schematics from 84, 88. So this was quite okay. This was second attempt, and as you can see, this was my first attempt of creating something on the 3D printer. Again, I wanted to show you this failure. However, the later versions were much better. It works. It has the dimension of the original parts. You can connect it. It's doing its part. The second version had no connector for the external power supply. It also used a module you can buy from China. Unfortunately, this is not really user-friendly because it doesn't have pins. So I know that we are short of time, but we have a demo. This recording was done, of course, on the one of the best DVD recorder. You use the proper technology for the proper equipment, so you will see the usual issues with the screen. So this is the terminal program that we used. Here you see the configuration. The 3 bounds were chosen. We will be describing what is happening later on, so don't worry if you will miss something. The 300 bounds was chosen just because it would be easier later on to poke around the video. Here there is a computer starting and communicating with Commodore. This is the first attempt of pulling the data from the model, from the parametric knowledge. As you can see, and you will see this later on the slides, a bunch of nonsense. Tiny Llama knows nothing about Commodore 64, okay? It is close to be Windows equivalent, whatever. Much better approach is to create a rack project. So we've put a PDF about the Commodore 64. We created a vector storage, and after asking the same question, the answer was very precise. And after this very proper answer, the chunks of data, the sources was also displayed. So yeah, this is very basic, naive rack. Naive is a type of retrieval augmented generation. You have here sources. You get the idea. Later on, we can edit the project, as you will see. I could have speeded up, sorry. But it's, as you can see from the parts of the description, the embedding model shows the parts very well. So we have everything correct, and we will have then the rack management. So yeah, that's it. Using this method, you can connect it to any other software. You can print it, whatever. So here I already told you. The question is why we didn't use 80 columns that can be software generated, for example, in Novaterm. The answer is for the quality of the output for you guys. If you are working with actual CRT equipment, then it's fine. But if you are grabbing it, well, you need to poke around a little bit, which we didn't want to do. Nice thing about this solution is that this user port with the exact pin out, voltages and everything, the communication scheme, was the same for VIC-20, for Commodore 64, for obviously the mobile version, the SX version, and Commodore 128. So we had several Commodore computers readily compatible with this module. This is how you can manage your retrieval augmented generation project. Here you have parametric knowledge, so knowledge from the small LLM itself. It's worthless. Don't read it. It's really abomination. And we have the rack project that is manageable. It works. The answers are very correct. Chunks, as I described before. Yeah, so let's back to the rules. How did we make it? Well, it must be similar to authenticated technology. I believe that we were successful in this field. Well, maybe the next version won't be green, but it's fine. I would say that it is a pass. Should be compatible with as many Commodore models as possible. Yes, this also worked. If you will look into the Commodore history, then you will confirm it that this was the best choice. We didn't want to compromise functionality. Yes, we didn't overtake anything. We didn't force the user to use some kind of memory extension that will just shut down any other software you can write or use from 80s. So this is also fine. Easily replicable? No. Unfortunately, at this point, there is both. The problem is with power supply. There is problem with cooling of these small computers. And there is a problem with ready modules, this Max 232. If you don't have a lot of experience with electronics, you may mess things up, and you cannot find these modules with already available pins that are directed downwards. You don't have it; it is not on the market, so you cannot buy it. You need to do this. And this is it a toy, or we can actually use it? Well, I would say this is usable, so you can do stuff with it. It's fun, but it's usable, it's responsive, you can put files inside, nice. So I believe that this computer needs to be replaced with something, anything, to be honest. This is not doing the job. I hope that the Raspberry Pi Zero in future version will be similar. Then we will be able also to use a dedicated AI processor that are starting to be very popular. And with the next steps, we will do some more things around it, depending on the crowd here on this conference. So guys, thank you very much. This was our idea that we put into life, and yeah, thank you. I heard that Commodore 64 was actually very popular here in Sweden, so I hope that you like it, and we will be here with Marek to answer some of your questions you may have. So thank you again.
Yeah, you guys are heroes, seriously, once again. Insane. Insane. I love it. So, do we have any questions, surely, right? No? Yes, there will be questions. You have to. Yeah, we have. No? Where? Any questions? You have to have some questions, guys. I am. This is amazing.
So,
Why?
why? Why again?
Oh, but it is epic.
Everything is on Commodore 64. You can
Obviously.
connect to it everything. So why not, hold upon it and again prove
Again,
to the other users that there is something even better.
Yeah, no, I am amazed. It's amazing. So, questions. We have a question here. Good, sir. Can we get a mic? We get a mic? Yeah, oh, we have one here.
So I'm just wondering, what about Atari then?
So, okay, that's an excellent question. Thank you. Okay, let me take that.
Is I'm offending you?
Again, please.
Is I offending you?
No. Actually, I have two factory sealed unboxed Atari 65XE in my collection. I know of these things. I've bought several of them to make sure that they are not better in any way. There are two things you need to consider if you are thinking of the Atari. So, three action. The first is you will have issues with machine learning. As I showed you before, these simple programs that you can write in BASIC and then compile, they will run faster. You will have this hard limitation on memory. Commodore 64 had 64 kilobytes, 52 available. Atari had less, 48. It was never fully utilized. If you want to have some kind of GPT-1 distilled version that came out like 2 months ago or something that is not really answering you but predicting next token, so you are asking for, I don't know, table and table standing, crossroads, building, and other nonsense, then you will need to have kind of memory extension for Commodore 64. This is Ryu, Gaoram, whatever, and you need to use paging, and this has to be extremely well optimized. Again, these are not very popular modules for Atari. They are not also well supported, so you will have a lot of issues. And the third thing regarding the external modules that you can have, well, I would say that the Atari didn't convince guys like me to do such thing.
Fantastic. I changed my mind. I'm going to sell everything and buy some Commodores.
Please do that. And another question.
Yep.
Hi, hello. You stole my question from before. I was going to ask the same thing, like what about Atari ST, the ZX Spectrum, stuff like that. But then another question in my mind came to, do you think that this trend of LLM models will be going to other types of hardware in form of a DMake? Or do you think like this is very complex and advanced to perform?
No, it's not really so advanced. I would like to remind you that IBM 1 year ago presented like passive LLM based on discrete elements. So they are trying everything. You have dedicated TPUs in small computers, in phones. You have everyone are attempting like not Grok from Musk, but the other one manufacturing streamlining processors for LLMs. Everyone are testing new things. Remember that LLMs were not the main force behind changing nowadays computers. So we are adapting current technology to LLMs, and I would say that very soon we can see very powerful models running on dedicated equipment or old equipment. Look what Chinese done with their QN model that was, and the DeepSeek that was also based on QN. They just didn't. They were not lazy, and they rewrite some of the CUDA parts of the software into the assembly of the actual CUDA hardware, and they just went skyrocketing with the performance. So it is only a matter of time when there will be much better module for this exact task, and I will come here with an update with some other functionalities, of course.
That sounds great. The reason I was wondering about that is that I think a lot of you know about the trend of does it run Doom? So then I was just like, are we getting a new variant of does it run LLM?
Well, apologies for not showing you the Doom. Yes, we have Doom for Commodore 64. A little bit better version is for Commodore VIC. But yes, there is Doom.
Thank you very much.
Thank you.
Thank you so much for a really good talk. Thank you.
Thank you.
Thank you, guys.